All right, now I'm going to completely abandon the area model. I might use it as a think piece, but the reason I might want to abandon it altogether here is, well, I know I'm factoring, so I got to set it equal to 0. So I'm going to get negative 80. So there's two reasons I really don't like this. One, having negatives just make the area model more difficult. As soon as you get to negatives, you're not really truly using an area model unless you're showing compensation, which is what I did in that one problem where we could see the overlay. So when you start doing it symbolically and changing colors, the area model is kind of losing its usefulness. And now that there's two negatives, and it's a large number, I don't feel like drawing 80 dots. It's not super useful. But what is useful is knowing with the area model, I'm always splitting that up evenly. So I know in my area model, I'm going to get an x minus 1 squared. I also know from that I'm going to have, all right, so maybe I just make a small sketch to myself. That x minus 1 squared is going to have 1 dot. So this pretty much has a plus 1 component to it. And that plus 1 is borrowing from the 80. So it's really like I gotta, take x squared minus 2x, and I'm adding a 1 so it fits my model. But I like to add a 1 and take away a 1, because that way I'm not actually changing anything. I can take away 80. All right, I also know my next step when I'm doing these area models is really I wind up with this ugly regular hexagon thing. And I know it's a difference of two squares. It's a little square biting out of a bigger square, right? Which is another reason this one sucks, because x minus 1 squared, it's taking away 81. It's hard to draw that in a way where this 81 is a little bit. So I know that the big square is x minus 1 squared, and I now know that I had 80 dots taken away, and then I had to borrow another one, so this thing up here is 81, which would be a 9 and a 9, and I remember that I cut this off, and I move it, so I know that it's x minus 1 minus 9, and x minus 1 plus 9. Alright, so minus 81 equals 0. You might show an algebraic step in between, like so. And then you get x minus 1 minus 9, x minus 1 plus 9. I get x minus 10, and x plus 8. Alright, so it's still standard form to vertex form to factored form. And so you could actually teach this in Unit 6, and then solving is literally just, well, this is when these intersect. When does this become 0? Oh, I plug in negative 8, I plug in positive 10.